All right, lesson 4.6, Arithmetic Sequences. Here we go. So we're going to learn how to find the terms. We're going to write the terms. We're going to graph them, and then we're also going to write the function. This will be something new for you guys. So you probably are used to seeing things like this, where you're given some numbers and you're asked to write the next 3 terms or however many. Well, what we have to look at is in these sequences, it's an ordered list of numbers, and each one is called a term. This a sub n, it has a specific position. So this very first number right here is in the first position. That's the first term. So 10 would be the second term, 15 is the third term, 20 is the fourth, the fifth, and it goes all the way, to infinity really, and you have the nth term, which is a sub n. So when we're looking at this, we're looking at a common difference between the numbers. So between 5 and 10 is adding 5, 10 and 15 adding 5, 15 and 20 adding 5. And so the difference between the terms is constant. So there's this constant rate of change happening. That's how we know that it's an arithmetic sequence. So extending the sequences. So what we're going to be doing, it says write the next 3 terms. So you'll want to look here and determine what is the difference that's happening. So when you go from -7 to -14, you're actually subtracting 7. -14 to -21, subtract 7. -21 to -28, subtract 7. So you want to extend that out. So that's 1, 2, 3, 4 terms. So if you make a table, a list of tables, it's kind of like you have an ordered pair, right? And we'll be kind of seeing that a little bit later in this lesson. But the position is like the input value and the term is the output value. And then we have this common difference of -7. So we want to then extend that out just like they've done. So from -28 to -35, from -35 to -42, and -42 to -49. So you're adding a -7, or you could, if you have it in your calculator, you could just be subtract 7, subtract 7, subtract 7, however you want to do that. Okay, so let's give ours a try. This is in your student journal on page 124. So we'll write the next 3 terms. So from 1 to 8, we are adding 7. 8 to 15, adding 7. So notice that we have this constant change. So our common difference, the difference in this case is adding 7, or it's a positive 7. So then we would take, so this is the first term, second term, third term, fourth term. 22 plus 7 would be 29. 29 plus 7 is 36, and 36 plus 7 is 43. So these are the next 3 terms. Okay, I want you to pause the video and give number 20 a try. Try to identify the common difference, but also what are the next 3 terms in this sequence. So moving right along to number 3. I'll do another one. Here we go. We have from 12 to 21 is going to be plus 9. 21 to 30 plus 9. 30 to 39 plus 9. So our common difference is adding 9. So from 39, if you add 9, you'll get 48, 57, and 66 for the next 3 terms. And this is the easy part. All right, so the next thing we're going to do is graph the terms. So when you graph the terms, you're going to want to write the sequence as ordered pairs. So the first one is the first position, so the input value would be 1. So it'd be 1, 4, 2, 8, 3, 12, and 4, 16. Then you can graph those points. So make sure that you are listing. So we have 1, 1. We have 2, 3, 3, 5, and 4, 7. So remember, this is the first position, second, third, and fourth. So that's how we get the ordered pairs. So if I just want to count by twos, I'll make this 0. I can graph. This would be the point 1, 1. Then we're going to have 2, 3. We'll have 3, 5. And 4, 7. Okay. For number 8, I'll let you work that one out on your own. And I'm going to be asking you a question on Edpuzzle to list the ordered pairs represented by this sequence. So be prepared to answer that. All right. So if we see a graph, we could then list the terms or the ordered pairs, right? Make a table and organize it. So we want to know if the graph actually represents a sequence, an arithmetic sequence. So looking at the table, right, do we have a common difference? So that's what we're looking for. If we do have a common difference, because what'll happen in a arithmetic sequence is it will form a line. So if it has a common difference, then it is a arithmetic sequence. And you can list the ordered pairs and determine if it is or is not. So let's give that a try. So right here, so we want to determine whether it is arithmetic or not. So we want to list, and in this case too, you can also, what we're looking at is the output value. So you could list the range, right? The range represents, because you make sure it's counting up by ones, 1, 2, 3, and 4. So then the outputs are 0, 1, 4, and 9. So from 0 to 1, we have plus 1. Then we have plus 3, and we have plus 5. Is there a common difference? No. So this is not an arithmetic sequence. Because there's no constant rate of change. Or we also call this the common difference. All right, looking at the next one, make sure the inputs are 1, 2, 3, and 4. So we'll go from 20 to 30 to 40 to 50. And each one is increasing by 10, right? Since we have a common difference. So yes. It is an arithmetic sequence. And the reason is because there is a common difference, also known as a constant rate of change. All right, so I would pause the video and try number 15, and then check your work on the Edpuzzle. All right, so now we're going to get into actually writing the function. So the big thing to keep in mind here, I'll let you read those words if you want, but a sub 1, what this means is this is the first term. So if the first term is 4, and D is going to represent this common difference, okay? So let's look at the positioning. We have 1, 2, 3, 4, and then it goes all the way to the nth term, right? The first one, a sub 1, first term, a sub 2, second term, a sub 3, third term, a sub 4, fourth term, all the way to a sub n. So when you're just writing this, we'll use numbers and we'll use our algebra. So we have a sub 1, right? To get to the second term, if you start at 4, you add 3 because that's our common difference. So we will add D in this case. So 4 plus 3, we get 7 as a second term. To get to the third term, right? From 7, we'll go to 10, which is like taking 4 plus, and then we have 2 times 3. Uh, then from 10 to 13, adding 3, which is like 3 times 3. So we kind of start to see this pattern evolve, that what we're actually going to be doing is we take our first term and we add n minus 1. So n is the term number that it is, okay? Um, times the common difference. Now, n can be anything, right? The reason we're writing this function is so that if I said, give me the 50th term in this function, well, I guess technically we could make a list all the way out to 50, but it would be so much easier if we could write this in a function like this or with the, numbers and then just plug in the 50 for n because that's the term. So that's what we're going to be doing now. All right, so we'll use this formula. So this is kind of the generic formula. A sub n is equal to A sub 1, first term, plus, n minus 1, n being the number of terms that we're trying to determine, and times d, which is the common difference. All right. All right, so we're going to write an equation for the nth term of this sequence, 14, 11, 8, and 5. Then we're going to find A sub 50. So when we examine the common difference, we're looking at how does this change from here to here, right? Well, it's subtracting 3. How does it change from 11 to 8? Minus 3, and 8 to 5, minus 3. That's how we get the common difference. A sub 1 is the first term. The first term is 14. So n will stay as our variable, n minus 1. And then we have this times this common difference. So we can actually distribute, all right? So what you get here is 14, and then you'll have minus 3n plus 3. So then you can combine the like terms, 14 plus 3, to get your starting point right there for the function, right? That will give us a sub n. Now, when we want the 50th term, we're looking at a sub 50. We plug in 50 for n into this function, and we would find out that the 50th term in the sequence is negative 133. So we are going to try a couple of those. All right, on this first one, we're going to look here at what's happening. So, one thing, if you're using a calculator, because it's decimals, you could put in negative 6.6 and then subtract the negative 5.4. And what you'll see is that the common difference is a negative 1.2. So it's decreasing by 1.2 each time. All right, we're going to use this formula, right? A sub 1 plus Rn minus 1 times the common difference. So we know that we can plug in this negative 1.2 back here. So what goes right here? Well, right here is going to be our negative 5.4. So A sub n is going to be equal to negative 5.4 plus, and then we'll have n minus 1 times this negative 1.2. So we'll distribute. And then we can combine these like terms. So we'll get A sub n is going to be equal to, and let's just go ahead and write it in kind of in function form. We'll have negative 1.2n, and then when we take the difference between 5.4 and 1.2, we should get 4.2. Yeah, 4.2. And it is negative, so minus 4.2. So here is our function that we want. Now, we're not done because we also have to find a sub 10. So if we're doing a sub 10, we're going to substitute in 10 for n. So we'll get a sub 10 is equal to a negative 16.2. So there's two answers here. Okay. I will do a couple more, all right, just so we can have a few more of these examples. So again, find the common difference, right? So this is another one that's decreasing. And the difference here is going to be minus 5. Okay, so D is equal to minus 5. So we'll have A sub n is equal to 43 plus n minus 1 times the negative 5. So we'll distribute 43 minus 5n plus 5, combine like terms. So A sub n is equal to negative 5n plus 48. Okay, then we're going to use that to find A sub 10 would be equal to negative 5 times 10 plus 48. So we'll have negative 50 plus 48, or A sub, oops, got a little messy here. A sub 10 is equal to negative 2. So there's your two answers right there. All right, looking at number 18. If you need to pause the video and try to work number 18 out, please do so. We're down to two more examples and then we are done. So from 6 to 10, plus 4, plus 4, plus 4. So A sub n is equal to the A sub 1, which is in this case 6, plus n minus 1 times 4. So 6 plus 4n minus 4. 6 minus 4 is 2. So A sub n is equal to 4n plus 2. Then we can, again, calculate A sub 10. 4 times 10 plus 2, 40 plus 2. So A sub 10 is equal to 42. So that's the 10th term. We could find the 100th term if we wanted to just substitute in a 100 in place of the n. So that's what's nice about this function. So I want you to go ahead and calculate numbers 19 and answer that question for me. So pause the video and calculate number 19. And that concludes our video.